Go.
Hi, I'm Emma. I'm Violet. I'm Cheristy, and we're Antipodes, and we're going to be presenting about maglev trains. So, what makes ground transportation inefficient? So, the reason ground transportation is inefficient is because of rolling friction. It's like if your car runs out of gas and you try to push it, it's really, really difficult. So, the equation for rolling friction is the friction force is equal to the coefficient of friction, or the slipperiness, times the normal force, or the weight. So we have three common technologies that we calculated the friction force for, and maglev is the only one with absolutely no rolling friction.
So in a maglev, there are three key components. There's the levitation, the guidance, and the propulsion system. The first part is the levitation system, and on the track there are two rows of magnets, and then on the train there are magnets, and they're the same polarity, and they push off and they repel each other, and that's what makes it float. And there's also a laser guidance system on the track that makes sure that it doesn't raise too high or lower too much. So if the train is carrying a lot of people, or if there are bad weather conditions, it won't hurt the train at all. The next part is the guidance system. And on the side of the track and on the train, there are more magnets that use the same repulsion system to keep the train centered on the track. And so things like when it's making a turn, it doesn't run into it. There's a laser guidance system that helps with that too. And the third part is the propulsion system. And with the propulsion system, there's another row of magnets that go along the track that go, instead of all the same polarity, it's north-south, north-south. And then on the train, there are Hall effect sensors that are stationed here, and they measure the polarity and the strength of a magnet, and it feeds that into electromagnets over here. And the electromagnets, as it's approaching, if the electromagnet reads that it's north, that it's, say that red is north and green is south, as it's approaching north, it'll pull towards it, but then as it approaches here, it changes to red so that it now gets attracted to here. And as it goes along, it just keeps on changing and changing and to keep it pulling along.
So the main question is, if maglevs are so efficient, why don't we see them everywhere? That's because they're so expensive. They're twice the cost of a bullet train, which puts them at the cost of $20 million per kilometer. And what makes it so expensive is labor, materials, and complexity. So our proposal is that we make a hybrid maglev. It will have wheels on the side, which will eliminate the whole guidance system. And you'd think it would cause a lot of rolling friction, but it actually doesn't, because there's almost no weight on the side of the car. As you can see here, we have calculated the force of friction for the side wheels. As you see, there's almost no weight, so there's almost no friction. And you'd have to sacrifice top speeds of 581 kilometers per hour, but it would still be efficient. And so we have been asked to present to Lego about making a maglev train kit. So kids can learn about science and technology in a fun way and learn more about maglev, so hopefully they'll be more interested about it in the future and think of creative ways to make maglev more efficient and other types of efficient transportation.
So we had a few experts review this to just revise it and see what they thought of our presentation. And so these are our sources that we use to get our knowledge and gain our knowledge and resources so that we would be able to make this presentation.
And on a whole, we thought that maglevs would be a great alternative to a lot of transportations nowadays because they're a lot more energy efficient and they get people there faster. There's the problem of cost, but in the future we'll probably be able to work around that. So that's why we think that maglevs are a great alternative to present ground transportation. Thank you.
Thanks.